Zalot studio channel, which is focused on simulation virtual lab. So today's lesson, that is capacitors in parallel. So that means the capacitors that connected in parallel. When a battery voltage V is connected across a parallel combination of the three capacitors as shown in the figure below, so all capacitors will acquire equal voltage here. The all capacitors that acquire it to be need it to be acquire what equal voltage. So total charge is that Q total is equals to C total times V of the circuit. Then Q total is equals to that the equivalent charges. The equivalent charge is equals to Q1 plus Q2 plus Q3 in parallel combination. Here come from the above equations that Q total is equals to Q1 plus Q2 plus Q3. So Q total means C total times V, that is equal with C1 times V1, which means Q1, plus C2 times V2, which is Q2, and C3 plus C3 times V, that is Q3. Here, to be taking the constant V, which means that all capacitors will acquire equal voltage V. V cancelled by V, so the total charge is equals to, which is Q1 plus Q2 plus Q3, and the total capacitors in parallel is equals to C1 plus C2 plus C3. So here it is the combination of the capacitors in parallel, C1, C2, C3. So the total capacitor, that is C1 plus C2 plus C3, and have the total capacitor, the total charge. Here is the total charge, and here is the total capacitors, and here total voltage. Okay, the total voltage is equal with the individual voltage V, 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 V. So cancelling out of V, C total is equals to C1 plus C2 plus C3. Total capacitor, or the equivalent capacitance, is equals to capacitance 1 plus capacitance 2 plus capacitance 3. Come back to simulation here in parallel. Okay, here it is the total capacitors, that is here C total, and have the supplying 1.5 voltage, and to be in parallel when to be the total capacitors, that is 2 microfarad, 2 times 10 to the power of minus 13 farad, and the charges, that is the charges that are stored into capacitance, that is 3 times 10 to the power of minus 13 coulombs, and also the potential, that is 1.5 voltage. So each of capacitance is 1 times 10 to the power of minus 30 farad, and 1 times 10 to the power of minus 13 Faraday. So here it is parallel connection. The total capacitance is equals to 1 plus 1, that is 2. Here it is a total capacitance. Total capacitance is equal with C1 plus C2. And the voltage supply into each, that is 1.5, because this combination is parallel combination. And what about the charge? The charge that is stored into the capacitance, that is 3 microfarad in each. 3 microfarad. Here mean charge mean total charge is equals to Q1 plus Q2. Okay, So Q1 mean here and Q2 is here. 3 times 10 to the power of minus 3, and that is the total. So the individual one is 1.5 and 1.5. 1.5 1.5 plus 1.5, that is 3. And to be increasing the capacitors, that is 3 capacitors, the 3 capacitors that is connected in series, that is connected in parallel, which is positive with positive terminal of the batteries that connect positive terminal of, or the positive plate of the capacitor, and the other positive plate of the capacitor that connected with the third positive plate. So positive with positive with positive, that is parallel connection. Here the 3 capacitors that connected in parallel, the total capacitance of a capacitor is 3 times 10 to the power of minus 13 Faraday, which means also C1 is 1, C2 is 1, and C3 1 times 10 to the power of minus 13 Faraday. So the total capacitance is 3. 1 plus 1 is 2, 2 plus 1 is 3 times 10 to the power of minus 13 Faradays. Okay, in the next time I will show 2 series and 1 parallel, series parallel connection, and 2 parallel and 1 series connection. Please again I say okay, subscribe me and to be like it and subscribe it. Thank you for listening and watching me. With